In this series of videos I'm attempting to repair this Olympia ESW 100-KSR electronic typewriter. This is an interesting machine. It's kind of a cross between an electronic typewriter and a dumb terminal. Now if you watch the previous videos you'll know that it had a fault with the power supply, and when I tried to power it up I just got a continuous tone from the sounder, which is very irritating. So I've temporarily removed the sounder. I'll refit that if and when I can get this working, but it means it won't be irritating us by making a continuous tone while we're trying to fault find on it. So it seems clear that the processor isn't running. So the processor in this machine is a MOSTEC 3850, quite an interesting device. There are three large ICs on the processor board. These were fairly unusual in that they were kind of an incomplete processor, and the way that the processor was organized, it didn't really have an address bus. It had a data bus, but the interface for external devices was really through a pair of 8-bit ports. And so there were support devices that, for example, enabled communication between the processor and ROM or RAM, and it was just used really to turn the data fed from the two ports into effectively an address bus. So that's what the second device does, and there's a third device which I think is just used as an in-out port or pair of in-out ports. So fairly simple layout we've got here. We've got the processor board, and then on the left we have the control board, which also contains the RAM along with the serial interface and the stepper drivers. It's battery backed to retain the data that's entered into the typewriter, and the batteries had leaked and caused some damage to the board. I haven't replaced the connector yet. I've just cleaned it. It does need replacing, and we found a fault in the power supply in the previous video, which I fixed. We now have all the power rails intact. One thing I've done since the last video is, you may have noticed in the video, if you look very carefully, that we were getting some occasional sparking and arcing around this area, and it turned out to be the second of the power devices. I removed it. It was this device, and if you're interested, this is a BDX53. It's just a Darlington transistor, but if we do a test on this, let's wait for this test to finish, then it comes up as faulty. And in fact, if you look at it under a microscope you won't be able to see this. There is a crack across the front. Now I don't know if this died or was killed, so I'm going to leave it out for now. What it does is it effectively enables the data lines and the control lines going down this ribbon cable, and this goes to the print head. So there are various lines on there for driving the ribbon stepper, that sort of thing. But I can leave that out for now. If it does start coming to life, I'll refit that and we'll deal with any issues that throws up at the time. I have also checked that the two power rails are going to the processor. So if we look at the data sheet for this, there are two power lines on this, and that's pins 3 and 4. So we should have 5 volts on pin 3 and 12 volts on pin 4, and we do. The 12 volts comes from the local regulator, and that was missing before because it was fed from the 35 volt rail that was not working. So both those rails are present, and what we'll do now is we'll power this up and we'll start probing around this processor, which is this device, and we'll see if there's any activity. I suspect it's stuck in reset, and hopefully it's not damaged. These devices are quite expensive and quite fragile, and if we get issues with the power supply, quite often it takes these out because of the nature of the architecture within them. So I've got a scope attached, I've got the ground lead attached to ground on the control board, and what we can do now is start probing around. The first thing we want to look at is to see if the clock is running. So we've got this 2 megahertz crystal here, and it's connected to the crystal oscillator. This has an internal crystal oscillator, and we should find that on pin 1 we're getting 2 megahertz. So I'll power the machine up. It won't beep this time because, as I say, I've removed the sounder, but although you can't see it, I can see the current meter on the bench auto transformer, and I can keep an eye on that to make sure it doesn't spike or we get any issues. If we do, I'll quickly turn the machine off. The power switch is already on the typewriter, so as soon as I power up the auto transformer, this will come to life. You may hear it start to buzz. Okay, so it's now running. What I'm going to do is check to see if we're getting a clock on the clock pin of the device, and we are, and it is almost exactly 2 megahertz, so that's quite good. It means at least it's working to a certain degree. It doesn't mean that much. Usually these fail on one or more of their in-out pins, in-out pin drivers fail. What we'll do now is I'm just going to randomly probe down here all the lines down this side beyond the power rails. Should be showing some sort of activity even if it's not doing what it's supposed to. So we'll just do some random probing. And we're getting no activity at all. What we'll do now is look at the reset line. As I said, I suspect this is held in reset, so this is pin 37 and it's reset low, so that should normally be high once the powers come up. So we'll check that and see what's on that line. Okay, so as you can see, that is low, which is kind of what we expected, and the device is obviously held in reset, which is why it's not doing anything. Maybe other faults, it could be that it's faulty as well, but certainly while the reset's low, it's not going to work. Now of course it could be this device is pulling that line low. Normally there's an internal pull-up within this device on that reset input, so what you can do is pull this out, get a 40 pin socket, cut the pin 37 off the socket, plug this into the socket, plug the socket into the board, and that should enable the pull up within this device to pull it out of reset. I'm not going to do that in this case. It's a fairly risky thing to do. The way these should normally work is the board, if it's properly designed, should hold the device in reset until the +5 and +12 volts rails have stabilized. Once they've stabilized, it's safe to take it out of reset. So I don't want to force it out of reset because there may be some other issues, and if there are, it could destroy the processor if it's not already destroyed. So what we're going to do now is I'm going to turn it back off, and we're going to trace where the reset goes. I strongly suspect it goes over here somewhere near the control for the backup battery. That's where we would normally expect to see the reset. So what I'm going to do is the reset line almost certainly comes through this ribbon cable. So I'm going to unplug this and then see if I can find one of these connections that goes through to the reset pin. And I'm just going to use the multimeter in continuity mode. Okay, I've unplugged this cable. Now obviously with a schematic this would be far easier. We could just look at the schematic, see where it goes to, and probe around to try and find the destination or the source for the reset control line. What I have to do here is start probing on these pins. So I've got the meter in continuity mode, and all I'm going to do is try and find out which of the pins on this connector we have the reset coming out of. So just try and find. Okay, that was a bit of lock, so it's pin 39. So it's pin 39, and what I can now do is we know that the reset line comes through directly to this connector, so I can plug this in And because we know now that the reset line is coming directly through to this board, I'm just going to probe around a bit and see if I can find where it goes to. I suspect it's coming over here somewhere, so all I'm doing is looking for where the reset line goes. Again, any luck there? So it comes through to there. Okay, so we know where it comes to on the board. What I'm going to do now is turn the machine back on, and I'm going to check here to see if the reset line is low over here and that we haven't got a break between the reset and the pin. I suspect we haven't, otherwise the pull-up within the processor would pull that line high, but we'll just check it anyway before we go any further. Okay, so it was that pin. Okay, and it's low here as well, so I'll turn it back off. So it's definitely stuck in reset. What I'm going to do now is the reset line is coming over to this area. Now, this is where most of the damage from the leaking batteries occurred, so chances are we've got either a damaged component or an open circuit track, and hopefully it's nothing more serious than that. There more than likely will be quite a few devices attached to the reset line. So what I'm going to do is probe around a bit, and although I replaced this transistor, this one is the original. I can't read what it says, that the writing on it seems to have been etched away by whatever came out of the battery, so I can't tell what type of transistor this is. But I don't have a schematic, so what I'll have to do is try and reverse engineer this a little bit. But I'm going to start by just probing about and seeing in general what we have on the reset line. I've got you zoomed in so you can see more clearly what I'm doing. I've still got the meter set in continuity mode, so hopefully you can hear that. And what I found is that if we go from here, this is the reset line, so these are all connected together. The reset line goes to quite a few different areas, but it also goes to certain power pins on some of the logic ICs. So in other words, the reset line isn't just the reset line, it's also an enable line for some of the control logic. So while that's low, the control logic is not going to be working because all these logic devices are effectively powered off. It definitely comes into this area somewhere, so the next thing I'm going to do is I'm going to take the board out and I'm going to start trying to reverse engineer this small area here. This is what I think is the reset circuit, so I'm going to see how this is configured. I'm going to take the board out, just draw this as a simple Dave CAD sketch schematic, and we'll try and figure out what's going on with it. Okay, I've spent a bit of time. I've reverse engineered what I think is the reset circuit, and although there are a lot of things attached to the reset line, which is this point, we can ignore most of them because they're actually being driven by the reset line, and this is the line that goes across to pin 37 on the CPU. So we have this device here, which, although I can't read the part number, the way it's configured would tend to lead me to believe it's a PNP transistor, and that's this device. So that's the one I didn't change, so it could be faulty. And this resistor pulls the reset line low when this transistor is turned off, and that's this resistor here. And then if we look across at this kind of makes a lot of sense. We have the plus 9 volt line coming in, so that's the one that comes in on this pin of the power connector. And when the plus 9 volt line goes high, it starts to charge this capacitor through this resistor. So that's these two components, that's the resistor, that's the capacitor. And this will start to charge up, and then once the voltage at this point gets above a certain level, this, which I believe is a Zener, again I can't see the part number, there appears to be a diode here, but I think it's a Zener diode, that will cause the base of the transistor to be pulled high. So rather than using a standard diode which would pull the base high almost immediately, using a Zener means that this voltage has to rise quite high before the base will rise high, and obviously this resistor normally keeps the base pulled low. Once this voltage gets high enough, it will turn this transistor on, and when that turns on, it will of course pull this point low, which will turn this transistor on, and it will effectively connect the reset line to the plus 5 volt rail. So that will not only raise the reset, but it will power up all the logic devices that are connected to this point. So it all makes sense. It's obviously not working. This point here is constantly low, so I'll start probing around and see if I can find anything. I suspect it may well be damaged due to the corrosion that this device I've replaced. This diode, it kind of measures okay, but you can't always tell with Zeners if they're working properly. The capacitor is not short, it seems to be okay, and this device, it measures okay in circuit, but again it could be faulty. What I'm going to do is start probing around and see if we can find anything. So I'm going to switch the multimeter to resistance mode. Unfortunately you won't be able to see the meter. In fact, what I'll do, I'll move the camera so you can see the meter, so it'll make more sense as to what I'm doing. Okay, so I'm going to start probing around this circuit and see if we can figure out what's going on. So we'll start from the base, work our way back and see if we can figure out if there's anything not working. If not, we'll put it back in the machine and start probing it with the scope. So going from the base of this, which is there, we should be connected to this point, which is a 270 ohm resistor. Which seems to be open circuit, so let's go have a closer look at that and see if I can see why it's not conducting. It might well be an open circuit resistor. Okay, so this is the resistor in question. You can see there's quite a lot of corrosion on the lead, but what you may not be able to see is the body is moving independently of the lead. I don't know if you can actually see that. So I push it a bit harder. It's actually not connected, so that would explain why it reads as open circuit. So I'm going to replace this resistor and we'll see if that improves things. I've replaced that resistor, and indeed, as you saw, the previous one was broken, and that resistor is this one. So without that resistor conducting, then this device would never turn on. I also probed a bit further once I'd replaced that, and also found that the emitter of this transistor is not connected to ground. So it should be, it looks like it should be, and this pin here connects to the emitter. So if I've got the meter in continuity, you can't see, but you should be able to hear it. So if I connect the probes from the emitter to this pad on what should be the battery connector, there's continuity, but that should also be connected to ground, although there's no direct link showing on top. On the underside of the board there's a continuous trace across all three of these pads. But there's no connection, so in other words, this emitter is not connected to ground. So again, with it in that state, there's no way that current can flow through this transistor, and so again this would never turn on. That's most likely because the battery is not fitted and the through-hole plating has been eroded away by whatever acid leaked out of the batteries. So what I'm going to do is just temporarily put a small link between this point on the board and ground, and when we refit the battery then that should automatically reconnect that. But I'll just put a link in there for now. I don't want to put the batteries back in at the moment until I've tested them. They may need replacing, but I do need this connected to ground or the reset circuit will not work. So I put a wire link in, and the emitter of that transistor is now connected to ground. So as far as I can tell, the reset circuit should now work unless the second transistor has failed, What I'm going to do now is put this back in the machine, power it up, and see if we get any further. Okay, I've got the boards refitted, and I still haven't refitted the transistor I took out, so it won't come to life properly if it does anything at all. What I'm going to do now is power it up. I've got the scope probe on standby, so what we're looking for now is to see if it comes out of reset. I can't find any other faults with the reset circuit, so in theory the reset line should now come high, and that would enable all the other logic that it holds in effectively inactive. Not quite sure what it's going to do. It's not going to print without this transistor fitted, but hopefully we'll see some action, or at the very least we'll get some activity on the processor. I don't know if these devices actually work, so what we're looking for here is to see if the processor is actually able to come out of reset and start reading data from the ROMs. So fingers crossed. I'm going to power it up. Okay, that was a fairly promising sign. The first thing this is supposed to do is drive to the home position when it's switched on. I think without this transistor fitted it's not going to be able to see the home position. I'm pretty sure that's responsible for enabling all the optocouplers that are part of that print head. So try it one more time. So that looks quite promising. What I'm going to do is just drop a transistor into that location on the board. So I've got a replacement for the one I took out. I'm going to drop this in. I'm not going to solder it in, I'm just going to kind of hold it in place and power the board back up and see what happens. Okay, try again. Okay, well it certainly seems to be working to a larger extent. I'm going to take the board out, solder this device in place, and see how far we get. Okay, I've replaced the transistor, so that should now enable the machine to power up the print head and tape drive, that sort of thing. I've also replaced the sounder. I hope I don't regret doing that. The one I repaired before just beeped once when I powered it up. But as I said before, it kind of depends on what the firmware is configured to do, so it might play jingle bells, it could do anything. But I'm going to power this up and hopefully we see a bit of activity. What it should do is drive to the home position, move back very slightly, and then we'll try pressing a key and see if it actually can do anything other than just reset the print head. Okay, that's looking promising so far. It's drawing about 170 milliamps from the mains, which is about what I would expect. I'm going to try pressing a key. Okay, well it seems to be working to a certain extent. Don't know what it's doing, and what I'm going to do now, the tape is obviously not loaded right, it's looping up. I'll turn it back off. Okay, well that's it for this video. We've obviously made some good progress. It's starting to come to life. Chances are that the CPU works. Hopefully it keeps working. They do sometimes have a habit of working for a short time when they've been inactive for a long time, then they fail. So what I'm going to do now is I'll leave it just idle but powered up for an hour or two, come back and make sure that it still functions, and then in the next video we can start looking at the rest of the machine and see what works and what doesn't work, but it's looking fairly promising.